Before we taught you about Riemann sums, now we're going to teach you the basic property of integrals. Okay, these are called definite integrals because before we were estimating the area under the curve. Now we're finding the exact area. Alright, when you take an integral, it has a few basic properties. F of x is the graph that we're going to find the integral of. That our f of x here is half x squared. The a equals your lower bound, and the b stands for your upper bound. 2 is our lower bound in this problem, and 6 is our upper bound in this problem. So essentially, we're trying to find this area underneath the curve. Remember to put your d of x there, because otherwise it's offensive notation, and you'll get points off from this triangle and the AP. Okay? So there's two different ways you can do this. The way to do it by hand is to take the antiderivative, and of course you can do it in your calculator. But let's take the antiderivative first. When we're taking the antiderivative, instead of taking minusing 1 from the exponent, we're going to add 1, because it's essentially doing the opposite of what the derivative is. Now, whatever number we would multiply by 3 to get a half is what our number will be there. So the antiderivative of half 0.5x squared is going to be 1/6x to the third. Okay? When solving our integral, though, we need to plug in our bounds. So here, we're going to plug in 6, our upper bound, and subtract our lower bound from it. When we work all of this out, we end up having 36 minus 4/3. That equals 104 over 3, or if we're going to 104 over 3, or if we're going to estimate with decimals, or not estimate, round, sorry, it's 34.667. That is what our area is underneath this curve.
Okay, this is the same graph we were working with before. Half x squared. Okay, the first way you can find the area underneath the curve or the integral is by using the graph itself. If you go to trace, or second trace, 7, and enter your lower limit, in our problem it was 2, enter, upper limit, in our problem it was 6, and hit enter, it'll fill out the graph for you, and we'll get the same answer we did before, 34.667. Now, if we go back to our home screen, there's another way we can do this. If you go to Math 9, see how it says integral? And we plug in y bars 1, comma, x, comma, your lower bound, which is 2, your upper bound, which is 6, close your parentheses, and enter, we get the same answer as before. So no matter which way you take, you'll always get the same integral.
Now, if we encounter a problem like this, where the lower bound is larger than the upper bound, we have to do something called switch indicate. We're going to rewrite our integral with 6 on top and 2 on the bottom, just like it was in our other integral. The upper bound always should be greater than your lower bound. However, you have to negate the integral in order to make up for that. Another thing we might encounter when doing integrals is having no bounds on the integral. When you have no bounds in the integral, don't worry, you can still take it. You write out your antiderivative, just like we did before, except this time you have to add c. C is your constant value, and you always have to add c if there's no integral.